So first of all, we have to know about the slope of a line. What is slope of a line? A slope, literally, the meaning of the term you can understand, and always in daily life also we used to use this term slope, and exactly that one here. Uh, how inclined a line on a certain plane or our xy plane, how inclined a line, a straight line, but it is measured with respect to x-axis. How inclined with a y-axis not. How inclined a line with x-axis. So in coordinate plane, always we consider x-axis and y-axis a set of axes which are mutually perpendicular, and their point of intersection we call it is origin. And from the origin towards right horizontally, that is positive direction of x-axis, and from the origin towards left we used to consider always negative direction of x-axis. And from the origin along y-axis upward direction, that is positive direction, and from the origin downward direction along y, that is negative direction of y-axis. And all of you are familiar with the set of axes in coordinate geometry. And slope concept is very fundamental and essential for straight line, because to study about existence of any straight line on a certain plane, on xy plane, first thing is to be observed. Definitely the straight line might be there on the plane in any direction. In any direction, a straight line might exist on a plane. So since direction wise its equation is different, so automatically the lines will be different. So first behavioral mm, thing regarding the straight line is inclination. So in different directions means with different inclinations lines exist. So but to define slope, only we consider inclination of the line with positive direction of x-axis. So automatically with negative direction of x-axis we will know, and automatically we will know its inclination um, with y-axis, positive direction or negative direction. But basically uh, inclination, that is in case of slope, we always consider along positive direction of x-axis. How much inclined a line with positive direction of x-axis? So since it is angle, so definitely some angle will be there, 20 degree, 10 degree, 30 degree, 45 degree, 60 degree, whatever. After all, it is inclination means is measured in mathematics, in geometry it is in terms of angle. So slope actually uh, uh, directly angle is not called slope. Slope is when we consider tan trigonometric ratio of this inclination of this angle, then it is defined as slope. Suppose a line is inclining with positive direction of x-axis 30 degree. This 30 degree is not slope. This 30 degree is inclination of the line with positive direction of x-axis. Inclination is not slope. Slope is defined in terms of inclination. So slope is defined as tan trigonometric ratio of the angle. That means if 30 degree is the inclination of the line, then slope will be tan 30. Tan trigonometric ratio 30 degree. So tan 30 degree, you know the value from the standard trigonometric table. Tan 30 degree means 1 by root 3. So 1 by root 3 is the slope of the line. So tan trigonometric ratio of inclination of a line is defined as slope. So if theta is the inclination of a line, then slope of the line is defined as tan theta. You can treat this as formula for finding slope of a line. So to know the slope of a line, we need the inclination of the line with respect with positive direction of x-axis. If theta is the inclination of a line with positive direction of x-axis, then slope of the line is tan theta, and it is symbolically denoted by small m. So it is universally accepted symbol, that is small m in coordinate geometry, two-dimensional coordinate geometry. It is always denoted as m, and m is the slope of a line. Now, another way is also slope defined. Slope can be defined in another way also. Uh, Suppose we do not know how a line, incline, how much inclination is there for a line. Uh, Suppose we do not know its inclination, that means we do not know the angle. Then another way is there to define slope or to find out slope. But if we do not know the inclination of a line, we must have two minimum points. We must have at least 2 points on the line, that is two coordinates, um, on the line. If any 2 points we have on the line, then with the help of that 2 points we can compute slope of the line. And that is what in this line here in the screen you can see. Suppose P is the name of the point on the line, x1 and y1 coordinate, and Q is another point on the line, x2, y2. Suppose these 2 points are lying on a particular line of which we do not know the inclination with positive direction of x-axis. But we have these 2 points on the line. That means we know 2 points. Their coordinates x1, y1 and x2, y2. Then with the help of these 2 points, we can write the slope. We can compute the slope using this formula. Just you can get it on the screen. Y2 minus y1 divided by x2 minus x1. That means difference between y coordinates divided by difference between x coordinates. So this ratio gives us directly the slope, not angle, not um, uh, any other result. It gives directly the slope, that is value of m. So difference between y coordinates divided by difference between x coordinate. So we have slope in two ways. First one, if a line is inclined with positive direction of x-axis at an angle theta, then slope of the line is tan theta. This is one form. And another way is, if we have 2 points on a particular line, then the slope of the line we can write in this way: y2 minus y1 by x2 minus x1. That means difference between the y coordinates divided by difference between x coordinates. So in these two way we can compute slope. So I do hope you have understood what slope of a line is. Now another thing, that is angle between two lines. Angle between two lines, we will need how to find angle between two lines. Suppose two straight lines are given. It will be given in the numericals in terms of equations. We will be getting later on how equations we can have for different types of straight lines. So when two equations of the lines will be given, or two lines will be given, and then we can compute exactly the angle between that two straight line. You know, when two straight lines intersect, four angles actually form, vertically opposite two pairs. When two lines intersect, four angles are formed. and one pair vertically opposite and another pair also vertically opposite. And if we know one angle, if we know any one angle, then automatically we can have the other three angles also, because just basic geometry you can use there. So angle between two lines to compute, we need some informations about the lines definitely. So that formula is this one. In the screen you can see this one. Tan theta is equal to plus minus m1 minus m2 divided by 1 plus m1 m2. M1 and M2, actually these are the slopes of two lines which are intersecting. Two lines will be given, two intersecting lines will be given, and when two lines intersect, suppose one angle is uh, formed there, considered, that is theta, then formula is this one. Tan theta is equal to this one, m1 minus m2 divided by 1 plus m1 m2, where m1 and m2 are slopes of the line. So that means we can understand, to have the angle between two straight lines, to have angle between two straight lines, we must have their slopes. If we know the slopes of two lines, we can compute the angle between the lines using this formula. You have to remember this formula. Tan theta equal to m1 minus m2 divided by 1 plus m1 m2. So here plus minus considered is an interpretation is there behind this plus minus. Actually, uh, when two lines intersect, if you observe, then one angle will be acute and another will be obtuse. If one is 30 degree, then another will be 150 degree. Another will be 150 degree. Vertically opposite, so 30 opposite again 30, 150 again opposite another, I mean that is also 150. So two different angles form actually when two lines intersect. So one is acute and another is obtuse. So acute means less than 90. So if one angle is 60 degree, then another angle will be 120 degree. So you know, tan acute angle means result is always positive. Value of tan theta for acute angle, that means in the first quadrant, always positive. And tan any angle greater than 90 degree and less than 180 degree, that is second quadrant. Tan with an angle greater than 90 less than 180, that means second quadrant. So that result is always negative. So that's why plus and minus, that is, for if theta is acute it would be plus, theta is obtuse it would be minus. So plus minus considered here. So to remove this confusion, we simply formulate with this one. Just below you see the relation, tan theta is equal to modulus, tan theta equal to modulus of m1 minus m2 divided by 1 plus m1 m2. So here plus minus is not written here, not considered. Instead of plus minus, we considered modulus, because modulus gives always positive result. So whatever value we get calculating m1 minus m2 by 1 plus m1 m2, that value, whatever it is, positive or negative, so that this result will be considered always positive because of this modulus. So tan theta is equal to positive value we will be having. So that means theta will be acute angle. That means this relation gives us the angle theta, and that theta is the angle between the straight lines. Suppose tan theta is equal to root 3. After computation of this, we are getting, suppose, root 3. Tan theta equal to root 3. So then theta will be 60 degree, because tan 60 is equal to root 3. So theta is equal to 60 degree, and that 60 degree will be the angle between these two straight lines. So this is the simple formula to find angle between two lines. Just we should have the slopes of the lines concerned. Now, two important conditions are there here immediately after this formula. Very important conditions are here. If the lines are parallel, then M1 is equal to M2. M1 is equal to M2 means slopes of the lines are equal. But when? If the lines are parallel, if the lines are parallel, their slopes are equal. This one very important condition. This can be said as condition of parallelism. When two lines are parallel, we must have M1 is equal to M2. That means their slopes are equal. So when two lines are parallel, their angle between them is 0. So tan 0 equal to 0. If we cross multiply this, you will have M1 equal to M2. That means if two lines are parallel, then their slopes are equal. Or conversely also you can say, if if slopes of two lines are equal, then lines will be parallel. So that's why this condition we can say condition of parallelism. That is, under what circumstances two lines will be said to be said to be parallel. So that condition is simply this one, M1 equal to M2. That means slopes are equal. If the slopes of two lines are equal, then lines must be parallel. Similarly, the second line is the condition of perpendicularity. If the lines are perpendicular, then M1 into M2 is equal to -1. That means product of product of the slopes, M1 into M2. That means product of the slopes. Product of the slopes is equal to -1. So this is condition of perpendicularity. That means under what circumstances two straight lines are said to be perpendicular. The condition is this: product of the slopes must be -1. That means if two lines are perpendicular, then their product of slopes is -1. Or conversely, we can say, if product of slopes of two lines is equal to -1, then lines must be perpendicular. So that's why these two lines are very important. These two conditions very important in case of different situations, uh, which are called condition of parallelism and condition of perpendicularity. And these conditions are related to slopes of the lines concerned. Collinearity of 3 points. It is just through examples. It would be convenient. Now we are familiar with slope. What a slope of a line is, and when two lines are called perpendicular, and when two lines are called parallel. So up till now we have understood this much about slope. Various forms of equations of straight line. You know, straight line uh, is a graphical phenomenon, that is a line. So many curves are there, so many two-dimensional curves, three-dimensional curves, lines, three-dimensional surface, three-dimensional planes. So, so many all different kinds of graphical structures are there in two-dimensional and three-dimensional geometry. two-dimensional and three-dimensional geometry. So out of all these structures, so one basic structure is straight line. So since it is on two-dimensional plane, so definitely we can draw it. We can draw properly on graph paper. And I know you all are familiar how to construct a straight line on a graph paper, considering two or more than 2 points on the graph paper. Plotting the points, we can construct a straight line. Now you see, since graphical uh, existence of straight lines, you can understand, you are familiar how a line is existent on a graph paper, how it can be constructed, how we used to construct it on a graph paper considering points. So definitely there will be some expression to represent these lines on graph paper. So that is called equation. So some algebraic equations must be there from which we can construct, we can draw a straight line on graph paper with proper manner considering points. So for particular straight line, there will be a particular equation. If the positions of the straight lines are different, so automatically their algebraic equations also will be different. And so ultimately we must be familiar with different types of equations of straight line, because from straight line only we can have its graphical existence. So when an equation is given to you, then it is possible to construct a graph or construct a line on the graph paper. So without giving equation, you cannot construct a line. You can just simply draw a line, no problem. But for that line, which graphical, which algebraic equation is represented by that line you have drawn on the graph paper, you will not be able to say. So that's why graphical, with graphical existence of straight line, there will be always correspondingly algebraic equation. So that equations we are going to actually study, how many types of equations are there and what particular elements will be needed to write equation of a straight line. So different types of equations of straight lines are there, and to write equation of straight line, to have an equation of a straight line, we must have some information. Like to define the slope of a line, we need 2 points, at least 2 points. Or to define the slope of a line, we need inclination of the line with positive direction of x-axis. So similarly, definitely to have equation of a particular straight line, we must have some elements, and these elements are sometimes slope of the line along with point, and sometimes more than 1 points, 2 points will be required, and sometimes other conditions directly or indirectly must be there to have the elements to write the equation of the straight line. So different situations, different requirements are there. So based on the context, based on the situation, we will be requiring the informations to write the equation of the straight lines. So I will continue from this equations of straight line in the next class, the various types of equations of straight line, various types of equations of straight line, and what type of elements are there, and accordingly direction wise how their equations will be changed, and parallel to the axis, how the equations are written parallel to the axis, parallel to x-axis, parallel to y-axis. So that much for today. Thank you so much.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.